Okay, we're going to talk about 3.5 graphing equations in standard form. And so the first thing to note is that we're actually doing standard form with linear equations, meaning x to the first power forming a straight line. Well, standard form is, for linear, is ax squared. Not ax squared, I just said it's x to the first power. So it's ax plus by equals c, where a, b, and c are all numeric values, x and y. X is your input, y is your output. Okay, so just kind of keeping that in mind there. Didn't need to write that. Okay, so one thing to note is standard form helps you to find your x and y intercept. And we're going to see that a lot when we're doing these. But just to remember, a reminder, if I have an x and y axis for each of these, and I want to find the x-intercept or show a visual of the x-intercept and a visual of the y-intercept. So let's say I just have some lines on these. Your x-intercept is where your equation crosses the x-axis, or your line crosses the x-axis. Your y-intercept is where your line crosses the y-axis. And it's important to note, if we were to label these, say like maybe this crosses at -3, and maybe this one crosses at 2. It would be important to note that this equation, right, or this line right here, would have an x-intercept at -3, 0. And this line right here would have a y-intercept at 0, 2. So you'll note that both of them have zeros. Your x-intercept is when y equals 0. And your y-intercept is when x equals 0. And that's going to come into play here in a minute when we try to graph these and solve some. So find the x and y-intercepts of a linear equation. Well, just like I said, your x-intercept is when y is 0, and your y-intercept is when x is 0. So if I want to find the x-intercept, what I'm going to do is I'm going to put 0 in for y. And that allows me to solve for x. You notice I get 2x plus 3 times 0. Well, that's 2x, because 3 times 0 disappears. It just becomes 0. So x is 9. That gives me an x-intercept of 0, or of 9, 0. And I can use that to graph it. You know, I can come down here and go, well, 9, 0. That's right there. Now, if I want to find the y-intercept, let's go ahead and switch up colors here. Okay, the y-intercept would be when x is 0. So I go, let's rewrite the equation. So now I just go ahead and put 0 in for x and solve for y. 3y equals 18. That disappears, it becomes 0, so y is 6. So my y-intercept is 0, 6. So go to 0, 6, that's right there. And notice that gives me 2 points. And if I have 2 points, then I can use those 2 points to draw a line. Oops, it'd be nice to hit the point. Okay? Use those 2 points to draw your line. All right. Let's fix up that line there. While I'm doing that, maybe you're looking at those other problems there. A little tougher when I can't put my, that wasn't much better, but use the 2 points to draw a line. So on this next one, I'm going to go ahead and find the x-intercept. I'm going to do it a little faster here. So we get -x, put 0 in for y. So we end up with -x equals -7, so x equals 7. Get the ordered pair of 7, 0. And then we'll go the y-intercept, so we have -x plus 7y equals -7. So we're going to put 0 in for x this time, so we get -0 plus 7y equals -7. And really, -0 doesn't exist, it's just 0. We get y equals, divide by 7, you get -1. So you have a y-intercept of -1. You have an x-intercept of, let's go ahead and and you have a y-intercept or an x-intercept of 7, 0. Okay, and then if you were to draw your line, I am having a hard time each time hitting that second point. So I'm going to try something here. Well, that's a little better. I actually tried to use a straight edge on my screen, which never tried that before, but there we go. All right. Okay, this last one, let's go ahead and plug in or substitute in. Oops. Let's kind of keep the same thing there. So let's substitute in 0 for y first. Okay, so we end up with that gone, and we end up with negative 5x equals negative 20, or x equals 4. So your ordered pair 4, 0. And since I'm a little shorter on room, go ahead and switch it up. Negative 5x minus 10y equals negative 20 here. So we're going to substitute in 0 for x this time. And that's now gone, and we end up with y is equal to 2. So we have the ordered pair 0, 2. So 0, 2 right there, and 4, 0 right there. And we'll try my straight edge piece again here. Boy, I think that was the worst one I've had yet. I hope you're using straight edge. If I'm going through all this extra effort here to use a straight edge, I sure hope that you guys are using them. Nope, I guess I actually have to have my pen selected there. Let's try that again. All right, well, not too bad. I think I'm going to have to, there we go. I'm going to call it good with that. Okay, so we've got those graphs done, and we've plotted our points, found some x and y intercepts. Perfect. Now, there are two special cases we need to be aware of. First, if x equals 5. You'll notice in this case you don't see a y. In all those previous equations we had on the other page there, we had x's and y's in each equation. Notice our line crossed both the x and y axis. Well, when you're looking at an equation and you just have x, that means it only crosses x. And it's crossing at that point. It's crossing at 5. So right here. You'll notice if I just kind of keep going, we'll just keep going upward. Yep. That is the line. X equals 5. And notice this one over here, it's really simple. You find negative 2 on y, it only crosses y. And notice it crosses right there. And if you just kind of keep going, well, there you go. No matter what x value you have, y is going to be negative 2. There's your line. Okay? So x equals 5 crosses only x at 5, and y equals negative 2 crosses only y at negative 2. That's all I've got. Well, good lucky to you.